Good morning to everybody. So today we will discuss about the topic clutch. So in the previous topic we have discussed about the chassis frame. So in that we have discussed about the types of chassis and types of chassis frame and different types of sections used for the chassis frame for both side and cross members. Then material used for the chassis frame. Then regarding the subframes and integral frames. The next component in the power transmission system is, say in this system there are so many components like a clutch, gearbox, propeller shaft, final drive, differential and live axles. So in this clutch topic we are going to discuss about the definition of the clutch, the functions of the clutch, requirements of the clutch, types of clutches, multiple choice questions on this particular session. So regarding this clutch, the function of the clutch, it is same as the coupling. So in the coupling, what happens? The power is transmitting from driving shaft to the driven shaft if both the shafts are mounted on the same axis. But even in the clutch, the function is remains the same. Here also the power is transmitted from driving shaft to the driven shaft. But the difference between these two, the clutch and coupling, is, say in case of coupling, what happens? The driven shaft is rigidly fixed to the driving shaft, so that you cannot disconnect the driven shaft from the driving in the middle. But in case of clutch, there is a provision to engage and disengage the driven shaft from the driving. So as such, there is no difference between the clutch and coupling according to its function, but there is a slight difference in its constructions. Therefore, the definition for the clutch, see here, the definition for the clutch, a clutch is a mechanical member which is used in the transmission system of a motor vehicle to engage and disengage the transmission from the engine. So this clutch we are not only using in the automobiles, even we are using in some other applications. So in case of motor vehicle, the position of the clutch is in between the engine and gearbox. And the same clutch we are using in some other applications like in stationary drives, that is a diesel thermal power plant. So in between the engine and this alternator, again we are using the clutch for connecting and disconnecting the alternator to the engines. Then regarding the functions of the clutch, one is to transmit the power from the engine to the gearbox, then from gearbox to the wheels through several components like a propeller shaft, final drive and the live axles. See here, when the clutch is engaged, the power flows from the engine to the wheels through the transmission system and the vehicle moves. So it means whenever the vehicle is in motion, the clutch is always engaged. So when the clutch is disengaged, the power is not transmitted to the wheels. Say if you operate the clutch pedal, say disconnect the driven shaft from the driving shaft. If the driven shaft is disconnected from the driving shaft, then there is no power to the gearbox. If there is no power to the gearbox, then there is no power to the wheel. Therefore, the wheels are completely free from this engine power. The clutch transmits the power from the driving shaft to the driven shaft only when it is in engaged position. So once the clutch gets disengaged, it will cut off the power supply from engine to the gearbox. Then there is no power to the wheels. So the third one, The clutch is kept engaged when the vehicle is moving. So once you release the clutch pedal or the clutch release lever, clutch lever, the clutch gets engaged on its own. There is a mechanism only for the disengagement, not for engagement. So therefore, the clutch is kept engaged when the vehicle is moving. And the fourth point, the clutch also permits the gradual taking up of the load when properly operated. It prevents a jerky motion of the vehicle. Sir, whatever the clutch we are using in the motor vehicle, it is always of gradually engagement and disengagement type. So here in case of automobile transmission system, we are not using this positive engagement clutch. We are always using the gradual engagement and gradual disengagement clutch. The reason is to avoid the sudden jerks. If there is a positive engagement and disengagement, then there is a jerky motion of the vehicle. Therefore, to avoid this, always we are using this gradual engagement clutch between the engine and gearbox. And the fifth one, the clutch is disengaged. It means we are operating the clutch withdrawal mechanisms in these four following situations. When starting the engines, it means at the time of starting the engine, we have to operate the clutch. Especially in the recent vehicles, recent cars, always we have to start the engines by holding the clutch pedal. The reason is in order to reduce the load on the starter motor. And the second one, when shifting the gears, at the time of changing the gears, we are operating the clutch. The reason is, say if you operate the clutch withdrawal mechanisms, it cuts off the power supply from engine to the gearbox. It means there is no power to the gearbox, so that we can change the gears to the required position, then we can release the clutch. That is, once the clutch cut off the power supply to the gearbox, then we can change the gears very easily without damaging any gear wheels. Then the third one, when stopping the vehicle. When stopping the vehicle means, to stop the vehicles, what we are doing, we are applying the brakes. So suppose if you apply the brakes fully without holding the clutch pedal, then the engine will stop. Therefore, even during braking conditions, in order to keep the engine in the running conditions, we have to operate the clutch pedal. It means first we have to operate the brake pedal fully, then we have to operate the clutch in order to keep the engine in running conditions. Then fourth one, when idling the engines. So even to keep the engine idling conditions, even in gear position, we have to operate the clutch. So in these four following situations, we are disengaging the driven shaft from the driving shaft with the help of clutch unit. Then regarding the requirements of a good friction clutch. So it means while designing the friction clutch, we have to consider these following aspects, or these are the factors to be considered while designing a good friction clutch. Here there are 9 requirements. One is the torque transmission. So here the torque transmission, so it is nothing but it indicates the capacity of the clutch. We have to design a clutch in such a way that the clutch has to transmit the 100% power from the engine crankshaft to the gearbox input shaft. Try to achieve this 100% power transmission capacity, but practically it may not be possible. So at least if you achieve more than 95%, it is a good achievement. Therefore, while designing this friction clutch, the clutch has to transmit the maximum amount of engine torque from the crankshaft to the gearbox input shaft. And the second one, the gradual engagement. The engagement of the clutch and even the disengagement of the clutch should be gradually. So this gradual engagement and the gradual disengagement, it avoids the sudden jerks. Therefore, to avoid the sudden jerks, the clutch should be engaged gradually. Therefore, we have to consider this aspect also while designing this friction clutch. It should be engaged gradually. Third one, the heat dissipation. See here, in this friction clutch, the power is transmitted from one shaft to the another shaft with the help of friction. With the help of friction. So because of this friction, the heat is generated. Because of this friction, the heat is generated. The amount of heat generated in the clutch unit, it depends upon the number of contact surfaces. It depends upon the number of contact surfaces. Whatever the amount of heat is generated in the clutch unit while transmitting the power from driving shaft to the driven shaft, and this generated heat has to be dissipated to the atmosphere as quickly as possible. Otherwise, it may damage the clutch components. So for this purpose, for every clutch unit, we have to provide some sort of cooling facilities. Say in case of dry type clutches, only this air cooling is more than sufficient. But in case of, if the heat generation is more, then instead of dry type, we have to go for the wet type. So it is wet type means we have to go for oil cooling system. So usually for single plate clutch, it is a dry type one, but for multi plate clutch, it is in the wet type. And even for this free circulation of the air around the clutch unit, we are providing the rectangular slots or the holes around the clutch cover. Then the fourth one, the dynamic balancing. See, especially for high speed clutches, the clutch transmits the power from one shaft to the other shaft by means of rotation. Therefore, for high speed vehicles or for high speed clutches, we have to test this clutch under static and as well as under dynamic conditions. It means we have to test this under static conditions, even if it is perfectly balanced under static conditions, but it may not be balanced under dynamic conditions. Therefore, we have to test this clutch even under dynamic condition also. Therefore, we can avoid the unnecessary vibrations and we can avoid the noise, and even we can avoid the damaging of the clutch components. So therefore, if you use an unbalanced clutch unit in the motor vehicle, it leads to the unwanted vibrations, and again it may damage the clutch components. Then there is an unwanted noise also. Therefore, to avoid all these difficulties, for high speed clutches, the clutch unit should be tested for static and as well as for dynamic conditions. Then the fifth one, the vibration damping. The vibration damping. The vibration damping means, so whatever the vibrations are occurs while transmitting the power from driving shaft to the driven shaft, these vibrations should be dampened out. So for this dampening these vibrations, there is a provision in the clutch plate that torsion springs are arranged around the clutch plate hub in order to absorb this torsional vibrations while transmitting the power from driving shaft to the driven shaft. Then the sixth one, the size of the clutch unit. The size of the clutch unit, it plays a very important role. So in case of four-wheeler chassis, the space is sufficient in the chassis, but in case of two-wheelers, there is a limited space in the chassis. Therefore, while designing this friction clutch, we have to consider the size. So if we minimize the size, it occupies minimum space in the chassis. So try to minimize the size of the clutch unit. So for example, for single plate clutch, it requires more space in the chassis, but for multi-plate clutch, it requires less space in the chassis. So that is why in case of two-wheelers, we are finding the multi-plate clutch instead of the single plate clutch, because the multi-plate clutch occupies less space as compared to the single plate clutch. Then inertia, the seventh one is the inertia. So here the inertia, it is mainly depending upon the weight of the clutch components. So if you are using this lighter weight for the clutch components, so that we can reduce the inertia. If we reduce this inertia, we can balance this clutch unit very easily. Therefore, try to minimize this inertia by using the lighter material for the clutch components without compromising its strength. Then clutch free pedal play. It's the eighth one, the clutch free pedal play. The clutch free pedal play, it plays a very important role in the friction clutch. So in every vehicle, say even it may be new one or the user vehicle, there is a free movement of the clutch pedal or the free movement of this clutch lever. So this free pedal play, it avoids the partial disengagement of the clutch. Suppose if there is no free pedal play, even the rider or the driver holds the clutch pedal or even the clutch lever with a little pressure, it may lead to the partial disengagement of the clutch. And because of the partial disengagement of the clutch, there is a loss of power transmission. And ultimately it leads to the excessive fuel consumption and uneven wear of the clutch plate. Therefore, to avoid all these problems, if you provide clutch free pedal play, even the rider or the driver holds the clutch pedal or the clutch lever knowingly or unknowingly, we can avoid the partial disengagement of the clutch. Therefore, the clutch free pedal play is necessary for every vehicle, and usually this free pedal play, it is about 10 to 15 millimeter. Then the last one, the ease of operation. So this ease of operation, it is also plays a very important role. So because especially for heavy transport vehicle, if the operation is more difficult, then at the end of the day, the driver, it becomes fatigue to the driver, because every time he has to put more effort for disengagement, because while driving the vehicles we are operating the clutch many times. Therefore, the operation should be very easier one, so that it gives more comfort for the driver. Therefore, the ease of operation is also plays a very important role. Therefore, while designing a good friction clutch, we have to consider all these 9 aspects. Then the next subheading is the types of clutches. Types of clutches. One is the positive engagement clutch, and another one is the gradual engagement clutch. See here, this positive engagement clutch means here the engagement and disengagement is positive one. It means sudden engagement and sudden disengagement. The example for this positive engagement clutch, that is dog clutch, which is commonly used in the constant mesh gearbox. In case of positive engagement clutch, the engagement and disengagement is the positive one. And the second one, the gradual engagement clutch. Gradual engagement clutch. So in this gradual engagement clutch, again there are 2 different types. One is the friction clutch, another one is the fluid clutch. The example for fluid clutch, that is the fluid coupling. The difference between these two, the friction clutch and the fluid clutch, is, say in case of friction clutch, the power is transmitted from driving shaft to the driven shaft with the help of friction. But in case of fluid clutch, the power is transmitted from driving shaft to the driven shaft with the help of fluid power. So in this friction clutch, again there are so many types. One is the disc clutch. Again in this disc clutch, single plate, multi plate and diaphragm type. And next, cone clutch, centrifugal clutch, semi-centrifugal clutch, vacuum clutch, hydraulic clutch and electromagnetic clutches. So here in this disc clutches, again according to the number of clutch plates and the type of the springs, there are 3 different types of friction clutches. One is the single plate friction clutch, the second one is the multi plate friction clutch, and third one is diaphragm type friction clutch. So in this single plate friction clutch, so it means that in this clutch unit we are using only one clutch plate. In case of single plate friction clutch, we are using only one clutch plate. But in case of multi-plate friction clutch, we are using more than one clutch plate. We are using more than one clutch plate. Therefore, this one we call as a multi-plate, the friction clutch. So in this multi-plate friction clutch, we are using two types of clutch plates. One set we call as the driving plates, another one is the driven plates. And the diaphragm type friction clutch means, say in case of conventional single plate clutch, we are using number of coil springs to exert the axial force on the pressure plate. But in case of diaphragm type friction clutch, we are not using the number of coil springs, we are using a single metallic diaphragm to exert the necessary axial force on the pressure plate for its engagement. Then the next example for the friction clutch, that is the cone clutch. So in this cone clutch, it is also one of the example for friction clutch. Here the driving and driven member, these two are conical in shape. These two are the conical in shape. As far as the efficiency of this cone clutch is concerned, the efficiency of this cone clutch is very high as compared to the disc clutches. But even then, we are not using this cone clutch in the motor vehicle. We are not using this cone clutch in the motor vehicle. The reason is, so in this cone clutch, once this clutch gets engaged fully, it is very difficult to disengage it. So therefore, this cone clutch is more suitable for stationary drives rather than this motor vehicles. So because of this reason, we are not using this cone clutch in the motor vehicle, but we are using this cone clutch in the stationary drives, that is in the thermal power plants. Then the centrifugal clutch. Next one is the centrifugal clutch. See here, the single plate, multi plate and diaphragm type friction clutch. These clutches are gets engaged with help of spring force. With help of the spring force. But in case of centrifugal clutches, there is no spring force, but the clutch gets engaged with help of centrifugal force. Therefore, this type of friction clutch we call it as the centrifugal clutches. And another name for the centrifugal clutch is an automatic clutch. And next one, the semi-centrifugal clutch. The semi-centrifugal clutch means it is a combination of spring and centrifugal force. So here we are using both the spring force and as well as the centrifugal force for fully engagement of the clutch. So in this semi-centrifugal clutch, the clutch gets engaged at lower speed with help of spring force, and as the speed increases, it takes the assistance of the centrifugal force for its fully engagement. Therefore, this combination we call it as semi-centrifugal clutch. Then the vacuum clutches, hydraulic clutch. So these two, the vacuum clutch and hydraulic clutches, these two we are classifying according to its actuating mechanism. So in case of this vacuum clutch, the working media in the circuit, that is in vacuum, but in case of hydraulic clutch, the working media in the hydraulic circuit, that is a fluid power. So and the last one, the electromagnetic clutch. So here with help of electromagnetic forces, there is an engagement and disengagement of the clutch. So this is about the different types of clutches which are commonly used in our motor vehicles. Then there are some multiple choice questions on this today's session. The first one, the following is not a friction clutch. The following is not a friction clutch. Here there are four options: fluid clutch, centrifugal clutch, cone clutch and disc clutch. So the following is not a friction clutch. One is the fluid clutch, centrifugal clutch, cone clutch and disc clutch. Can anybody answer this question? See here, in these four options, Centrifugal clutch, it is also one of the example for friction clutch. Cone clutch is also one of the example for friction clutch, and the disc clutch is also one of the example for friction clutch. Therefore, the right answer for this particular question, that is fluid clutch. The right answer is a fluid clutch. And the next question is, the following is known as positive clutch. See here there are four options. One is the single plate clutch, the second one is the cone clutch, third one is the dog clutch, and the fourth one is the centrifugal clutch. So the single plate clutch is a gradual engagement clutch. Cone clutch is also a gradual engagement clutch, and centrifugal clutch is also a gradual engagement clutch. Therefore, the example for positive clutch, that is dog clutch. So therefore answer is C, dog clutch. So we'll go to the next question. The following type of clutch is used in constant mesh type gearbox. One is the single plate clutch, second one is the fluid clutch, third one is the dog clutch, and the fourth one is semi-centrifugal clutch. So out of these four, single plate clutch we are using in the transmission system, not in a gearbox. Fluid clutch is also used in the power transmission system, not in a gearbox. And semi-centrifugal clutch, it is also used in the power transmission system, not in a gearbox. Therefore, the right answer for this particular question is C, dog clutch. C, dog clutch. Then next question is, the following is an automatic clutch which is controlled by the engine speed. The following is an automatic clutch which is controlled by the speed. One is the cone clutch, second one is the centrifugal clutch, fourth one is the fluid clutch, and third one is the fluid clutch, and the fourth one is a disc clutch. See, in the cone clutch there is a withdrawal mechanism. It means there is a clutch withdrawal mechanism, and in the fluid clutch there is also the withdrawal mechanism, and in the disc clutch, it may be single plate or multi plate, there is a clutch withdrawal mechanism. But in the centrifugal clutch, what happens? The operation of the clutch is completely controlled by the engine speed or by the accelerator pedal. Therefore, the right answer for this question is the centrifugal clutch. Just we will see the answer, that is centrifugal clutch. So these are the books I have referred for this session. One is Automobile Engineering Volume 1 by Dr. Kirpal Singh, and another one is Automobile Engineering by Bangai Nathu Singh, and third one Automobile Engineering by S.K. Gupta. So before concluding this session, just I will summarize this session. So regarding the definition of the clutch, as you know, it is a mechanical device or the mechanical member which is used to engage and disengage the transmission from the engine. And regarding the functions of the clutch, one is to transmit the power from engine to the gearbox, then from the gearbox to the road wheels through the propeller shaft, final drive, and this live axles. And the second one, say if you operate the clutch pedal, it disengages the driven shaft from the driving, then there is no supply of power from engine crankshaft to the gearbox. If there is no power to the gearbox, then there is no power to the wheels. And the third one, when the vehicle is in motion, it indicates that the clutch is always engaged. And the fourth one, so this clutch unit also absorbs some vibrations while transmitting the power from driving shaft to the driven shaft. And again, this clutch helps at the time of starting, at the time of changing the gears, and at the time of idling, and at the time of applying the brakes. Then regarding the requirements of the clutch, there are basically 9 requirements. One is the torque transmission, and the second one is the gradual engagement, and the third one is the heat dissipation, and the fourth one is the size of the clutch, and the fifth one is the inertia, and the sixth one is the dynamically balancing, and the seventh one is the clutch free pedal play, and the eighth one is ease of operations. So like this, totally there are 9 requirements for a good friction clutch. Then regarding the types of clutches, basically there are 2 types of clutch. One is the positive engagement clutch, another is the gradual engagement clutch. So in the positive engagement clutch, the engagement and disengagement is positive one, but in the gradual engagement clutch, the engagement and disengagement is gradually. And in this gradual engagement clutch, again there are 2 types. One is the friction clutch, another one is the fluid clutch. The example for fluid clutch is the fluid flywheel or the fluid coupling. Then the examples for this friction clutch, one is the disc type clutch. Then again the disc type, there are 3 types: single plate friction clutch, multi-plate friction clutch, and diaphragm type clutch. Then the next one is the cone clutch, and after that cone clutch, centrifugal clutch, semi-centrifugal clutch. Then according to its actuating mechanism, vacuum clutch, hydraulic clutch, and this electromagnetic clutch. So all these points we have discussed today. So after this class, just to go through the content, that is through the study material, even through the PPT and videos. So if you have any doubts regarding this particular session, so you can contact me over the telephone or through the WhatsApp, or even personally, if it is possible, you can come to the college and we will clarify our doubts. So with this, I will conclude this session.